If humanity is to become a multiplanetary species and have people living and working on the moon and on Mars, we need to ensure that we can grow food locally for them.
3, 2, 1.
We've had 3 successful space launches, and we're the first lab to say that the plants that we engineered for the spaceflight environment grew better than the wild type.
Space is a stressful environment because of the lack of gravity. The Gilroy Lab studies how plants grow in space to better understand what it might take to have strong growth and good yields to support astronaut health. A lot of students at the University of Wisconsin have been involved in helping us explore the research that we're doing with NASA.
We need to work with engineers and computer programmers to develop new tools in order to create stresses on Earth that replicate the spaceflight environment. This work can be used as a roadmap in the future to accelerate the adaptation of plants to the spaceflight environment.
Passion. You've just got to do what you're really interested in. What was it? Someone once said, if you practice something every day for 10 years, you get good at it. And so there was a few things I wanted to do. One of them was like fire dancing. That evolved into capoeira and like martial arts and performance dance and those types of like cultural forms of expression that help develop character and confidence. At the same time as that, it's just like my passion for plants, and then applying that same kind of like drive to growing plants as many different ways as possible. And then on the way, never underestimating the importance of the people that you meet. It's the journey that you go on. As I showed you earlier, the map of the different locations that I went to. I went to those places because of mentors that I was able to find through academia. Like the degree isn't that important. Like the paperwork is irrelevant. It's the people that you meet along the way. That's what takes you to your next adventure. Mum. We used to play a game like where you dig a hole in the garden and you had to put the plant in it and fill it with soil. It's until I realized my mum was putting me to work. And then I got to meet a scientist too. So I realized it wasn't just like growing plants because they're beautiful or growing plants because they're tasty. It was also just growing plants because they're like intrinsically interesting. And if you look close enough at them, you find these new patterns that you overlooked. Again, that's why I got so passionate about time-lapse photography, because you get to see them move like in a different way. You know, they work at a different speed to us, but they have to respond to the same environment as us. So like their circadian rhythm, their oscillations as they go through the day is intrinsically defined in their genomes, just like us is in us. And so when we put those things in a place where they don't have the same day-night cycles as us, and they don't have those same things like gravity, like how does the circadian rhythm like get out of sync? And how does the knowledge of how that works in plants affect humans and vice versa? Because when we look at the genetics of all organisms that like NASA put in the space flight, we see the circadian rhythm is responding in all of them. And so it was not just my passion for plants, but my passion for knowledge and the way all these things interlink. And that's kind of what got me into genetics, kind of seeing through the things as being like independent entities, and essentially seeing everything as being interlinked by like strings of information. But that's amazing. Abstract. We build a big metal box around it, and then we send up air from Earth that gets compressed in Florida, and then we fill that metal box with Floridian air, and then we send humans up there in like SpaceX capsules, who then put like water onto seeds below purple lights. Well, so far it was the SpaceX 13 launch. We call it Project Apex 05. So every NASA project has an opnom, a code name for the project. Apex 05 was the opportunity that I had to accompany Dr. Swanson and Dr. Gilroy to the Kennedy Space Center, where we did an experiment where we sent a plant called Arabidopsis thaliana to the International Space Station, and it grew on orbit for 8 days. And the astronauts got Tingle, took photos every day, allowing us to see like the physiological development and measure that over time. He then fixed the samples in a chemical fixative and froze it to -80 degrees, and they sent it back down to us in the Dragon capsule. And we were then able to get those samples back and analyze the genetic patterns. And so to kind of go through this experience has just been awesome, unreal. Yeah, it's never linear. Like you see a lot of people go, I want to work in aerospace, and maybe that works for some people, but it's more about developing the skill sets that are related to it, and then if you're lucky, like the planets align. It's just about following your passion. I think that's the most important thing. And if your only passion is to go to the moon, well, good luck. I mean, it is possible for some people in your generation. But like, there's a lot of other awesome things that are part of that journey, and it's so much fun just being part of the production.
Yeah, absolutely. Thank you. And can you just briefly describe the Space Chili Challenge that we're going to be sending out to these students to participate in?
Yeah, sure. So my friend Jacob Torres, he's founded the Space Chili Challenge. So he's working at the Kennedy Space Center as part of the Veggie program for astronaut health. And so he's going to be the first one of his team are going to be the first people to grow chilies on the International Space Station in the veggie, in the advanced plant habitat. And so as part of this, what they want to do is see what they can learn from other scientists around the world through having lots of people do their own ground control. So essentially, he's willing to send seeds to anybody and everybody that's involved. There's now like thousands of participants around the world. And you can join this program too. So if you reach out, there'll be some links shared. He will then send you the same variety of seeds, the exact same batch, they're going to the space station. What we are then doing, researchers around the world, some in Sheffield, some in Kennedy Space Center, some in Japan. What we're all doing is trying to do our best to build a built environment, to build a hydroponic system with lights, and document how we do it and share that information with the researchers at Kennedy Space Center. And then we're going to share data about the plants and try and see if we can find some patterns. If we all collaborate together, will we see some certain trends that kind of pop out? Similarly to that, at the same time, we're just in the next year we're launching the Space Microgreen Challenge. We don't have a launch date for the microgreens in space. That's why it's on the back burner, so to speak, because it's really great to tie these two things together. But essentially, that same kind of principle, like perhaps you students, you teachers, you might want to like grow some crops in the same way that astronauts are going to be doing, and microgreens are that other opportunity. And so again, we'll be sharing the link to the microgreen challenge to go along with the Space Chili Challenge.
Fantastic. Thank you so much. Some really exciting opportunities there and some really interesting insights into your career and your research.